Hello everyone, welcome back to my channel. Hope all of you are doing great. In this video today we're gonna discuss BGP message. So let's get started. Here in this section I'm going to explain the BGP message, and I always refer the below diagram for the explanations. Now what is BGP message? BGP basically use message to exchange the informations for establish and maintain the BGP connections or BGP neighborship with its peer, right? Now BGP basically use four type of message, as you can see: open message, update message, keep alive message, and notification message. Keep in mind BGP always use four type of message to establish and maintain the BGP neighborship, right? That is open message, update message, keep alive message, and the notification message. Now these four type of message are used to exchange routing informations, routing update if there is any update or not, and it's also help to check the error detection if there is any error or not, right? And it also helps to check the peer liveliness. What is the peer liveliness? Whether this peer is alive or not, right? So now, as we know, the BGP use TCP as a transport protocol, and it's use port number 179, right? So I always refer whenever I refer the TCP port, then it will be definitely port 179. This is very important and keep in mind, right? Now let's understand one by one, right? First I will explain the BGP open message, then I will go ahead update message, keep alive message, and the notification message one by one in depth, right? Let's start with the open message. So before jumping to the in-depth open message, we have to understand one thing, that is when this open message get initiated or when it sends, right? Let me explain this part. Whenever you configure in any router BGP, then you configure the neighbor with the ASN number, instantly the router send the TCP connections to the configured BGP peer using the port number 179, and it's also listen for incoming TCP connections and waits the connection gets complete. Now if the TCP three-way handshake successfully gets completed, right, then only the router sends an open message to its configured peer, right? This is the time when router sends the open message. We understood. Now how do I check, how do I see when the open three-way handshake gets completed and this open message gets sent? If you take a advantage, or if you use any packet capture tool like Wireshark, right, you can check similar kind of snap, right? This is the three-way handshake: SYN, SYNACT, and ACT, right? The source 16.1.2 sends and SYN request to destination 1.1, and its response, the 1.1 response to 1.2 with the SYNACT, right? Then again 1.2 response with the acknowledgement, right? So this is how the three-way handshake gets complete, and it's visible for you if you use the any packet capturing tool, right? And then only it sends a BGP open message, right? All right, now we understand how, which time the BGP open message gets sent, and how to check the three-way handshake gets completed and open message gets sent. Now we have to understand more. We have to understand more in depth. That's what we are here, right? Now that is fine. The open message is getting sent. They are receiving the open message, but what this open message contained, right? We have to understand this part also. We have to open this envelope. Well, let's open this envelope. Let's open this open message, right? So if I open this open message, it's contain BGP versions, my ASN number, hold timer, BGP identifier, optional parameters, right? These 3 to 4 options it sends, almost 5 options it sends content, right? So with this open message, this BGP routers sends BGP versions, AS number, hold timer, BGP identifier, BGP optional parameters, right? Now understand one by one each content, right? So first content was BGP versions, right? So what is BGP version? It sends whatever the versions BGP do this router is use, like I can say, give you example, the version 4, it sends the own version number. Hey router 2, I am using the version 4, right? This is my version. If this two router BGP version mismatch, right, then the PR will not get established because version should be same, right? All right, now we explain the ASN number. It's also sent own ASN number. That's what I have written over here. My ASN number. Router 1 sends, hey router 2, this is my ASN number. Please tell me your ASN number. Now this ASN number determines whether it will be IBGP or eBGP. Because if it is different AS number he received and sends, then it will be eBGP. If it is same ASN number, then it will be IBGP. All right. Now understand the hold time. What is hold time? Hold time nothing but I would say the waiting time, right? Let me explain over here. This is router 1, this is router 2, right? Now this router sends my hold timer is 180 seconds. It's mean I will wait 180 seconds. Till then, if you don't send any update within this time period, I will treat you as a dead, right? You are no longer my peer, right? So this is called hold timer basically. Now in Cisco router, you can say the 180 seconds is the by default hold timer, right? This is the by default hold timer value. Now another very important part is over here. If the router hold timer value doesn't match, right? If some router having a hold timer value configured 100 and if one Cisco router having a hold timer value 180, then in that case it will not tear down. It will negotiate and final the lowest hold timer value, right? And it will mutually agreed, right? This is the my hold timer. We are agreeing that this is the 100 millisecond 100 seconds would be our hold timer value, right? And the minimum hold timer value should be 3 seconds, right? And if you want to disable the Keepalive, whenever I will explain the Keepalive, then I will recall this part, right? All right. Now BGP identifier just nothing but the router ID. It sends own router ID. It's 32-bit unique router ID, right? It's used to prevent loop, as you know, and the router ID must be highest configure, right? Must be configured. If it is not configured, then it will take the highest loopback IP addresses. You can configure the router ID by using the BGP router ID command, or if you have not configured the BGP router ID, it will take the highest loopback IP, right? And even if you don't have the loopback IP, it will take your highest interface IP address, right? It's very similar to OSPF protocol. The same way, first you have configured, then it will take the treat as the router ID. If you have not configured, it will take your highest loopback IP address. Still, if you have not configured the loopback IP address, it will take the highest interface IP address, similar to OSPF. Now, what is the optional parameters? Optional parameters, it's reserved for the future expansion or future use. Like if you want to change in this router the open message, you no need to change the versions. You can include in the optional parameters. Like you can check if you take any packet capture, in that field you can check the MPBGP would become in the optional parameters, right? All right, hope you understand the BGP versions, my ASN number, hold time, and the BGP identifier, right? These all the stuffs contained in the BGP open message. Now, how do I check again? How do I see all these stuffs under the BGP open message? Again, if you take a packet capture of any tool, it will look similar. I have captured for you. Now, this is the open message, right? Is been sent. Now I have expanded this thing where you can check the BGP versions is mentioned, all right, and the ASN number is mentioned, and the hold timer 180 seconds, as I told you, that is also mentioned over here, and BGP identifier. Here I have not configured the loopback IP address, even physically I have not configured the router ID. That's what it's take the physical interface IP address as a identifier or the router ID. It's pretty simple, right? Now optional parameters, as you can see the optional parameters is it's almost blank. You can use for your other MP BGP kind of stuff. In that case, you can find out your detail over here, right? All right, everything is clear, right? Makes sense. Now time comes to update message. Here we'll understand the what is update message basically, right? So update message, before understanding the update message, we have to understand when this update message gets sent, right? Like open message. Now when the open the two router establish a neighborship, then only this two router is ready to exchange the routing information or the routing updates, right? So after establishing the neighborships, then only they can start exchange routing information or update messages, right? This is done within the update message, all the routing informations. All right, now if you if any prefixes are added, right, or removed, that will be comes under your update message, right? That I will also explain. Now here in BGP protocol, the prefixes called over here as the NLRI, network layer reachability informations. All right, so any prefix, any subnet will be called over here or referred over here as the NLRI. That I'm going to explain to you. Now NLRI and the withdrawn routes, what is this? Now let me explain over here. In router 1, if I add one network, right, and I'm going to add one network, that is 192.168.1.0, right? And this network I have added, and I have advertised this network by using the network command. So what happened? This network will be updated to this router 2 using update message, and that is called over here as NLRI, right? Whenever you add any network or prefixes and that you are going to advertise, that will be updated in the update message, and that will be treated over here as a NLRI, right? Now another part is the withdrawn routes. What is that? Now in case if you remove this route, suppose you don't require this route, it was temporary basis, right, for your specific purpose, then you will remove this. Whenever you remove this, that is also sent via the update message, and that will be comes under the field of withdrawn routes, right? So whenever I add it, that will send using the update message, that will refer over here as a NLRI. And if I withdraw any route or if I delete any route, it will be treated as a withdrawn routes, right? Now the update message also include other important part, that is mandatory attributes. Few attributes also, mainly AS path, next hop, local preference, all the made, origin, all these path attributes also been sent. This is very important, right? And what is the path attribute, that I have explained in separate video. You can check out from the I button. From there you can check what is the path attribute and how it's been selected, right? So all this path attribute also been sent by in update message. Within this update message, all these path attribute, withdrawn route information, NLRI informations, all these stuffs been sent. And these attributes, one thing very important, and this path attribute are stored in TLV format, right? That is time length value format. Now how do I check all this stuff? Again, I have captured the packet using the Wireshark, where you can see what I did. I have initially added one route over here, as I told you, 192.168, and that I have removed. Now let's see what happened over here. Now path attribute, as I told you, the path attribute, it sends the all path of the origin, right, the AS path, the next hop, the made value, all these stuffs is been sent under the update message, right? So path attribute being sent under the update message, right? And NLRI as I told you, I have added one network that is called 192.168.1.0 that I have added, and that is also reflect under the NLRI. In BGP protocol, whatever prefixes you are adding, deleting, that will be treat over here as a, or refer over here as a network layer reachability information, NLRI, always, in everywhere, right, in BGP protocol. Now withdrawn routes, I have removed the route and it shows or reflect in the withdrawn route lens, right? Automatically it will come whenever you withdraw the route. It will also come under the update message, right? And it will show the withdrawn routes is this. All right, makes sense, right? This is how you can capture the packet, and you can check what is happening under the hood, right? Now this is the time to understand the Keepalive message, right? It's very simple, it's very easy. BGP peer Keepalive message determine whether link or host failed or no longer available. What it mean that, right? So if this router 1 and 2 don't receive any Keepalive message from his neighbor within the whole timer, it will treat his peer as a he is not alive, right? And the default Keepalive message interval is the 60 seconds, right? Which is 1/3 of your hold timer. Always, this could be your interview question or any discussion topic. Keep in mind, your hold timer would be 180 seconds by default, and 60 seconds the Keepalive would be the default. The hold timer could be negotiable, right, with other non-Cisco router, and this hold the Keepalive should be 1/3 of your hold timer, always. Now these messages are sent as I told you every 1/3 of negotiated hold. Here you can see negotiated hold time. Why it is negotiated? If if router 1 is saying Cisco router, my hold timer is 180 seconds, but another vendor come here, non-Cisco router, he is saying my hold timer is configure 100. Now as the negotiation value would be lower one, so the hold timer would be final as a 100 seconds, right? And that would be 1/3 of your Keepalive link. Very simple. By default, Cisco device have a hold time of 180 seconds. As I told you, the 1/3 is a 60 second, right? So every 60 second, one Keepalive link, one Keepalive message gonna send to his peer. All right. Now, if a BGP never misses the key, as I told you, BGP misses any Keepalive message within the hold timer value, it will be treat, or it will be terminate the BGP sessions, right? Never ship. It is informative. Now if the hold time value is 0, then no Keepalive going to send, right? It's very simple, because 1/3 of the hold timer is the Keepalive should be. Then if you are setting the 0 is your hold timer value, then how do you send the Keepalive? It's very simple. Now BGP Keepalive message are very simple and contain only BGP header. It's very simple, it's lightweight, there is no data it's content at all about, right? There is no data, it's just a kind of header it's added as a Keepalive, right? All right, hope it is informative. Again, how do you check if you capture any packet? Here you can check the Keepalive message, right? The similar way it will show you the Keepalive message, and that is the BGP Keepalive message, source and destination, all the stuffs, right? So first 3-way handshake gets complete, then open send, then some Keepalive going to send, but before that some update message would be there, right? All right, now time to understand the notification message. Now what is notification message? It's notification as its name, right? It's notified to his peer. A notification message is sent with an error detections, right? If there is any error with the BGP peer, it will send to his BGP peer there is an error, such as hold timer expiring, like neighbor capabilities change, or if I change any neighborship configurations, or the BGP, if I reset the BGP session, right, IP clear BGP star soft or something like that, then only it will notify to other. Even if it is down, then in that case also it will notify. Notification provide the bad messages also, right? If you wrongly configure, badly configure, then that also be sent. Notification sent if there is any misconfiguration, as I told you, right? If you configure any misconfiguration, in that case the BGP notification will be sent to his peer. Now overall BGP notification message are critical. Definitely it is critical, detecting to reporting the error, right? Whatever error is happening, the notification message responsibility to send to his peer, right? All right, hope you understand. Now if I take packet capture in that scenario also, what I did something different, right? So what I did, I have configured intentionally the router BGP is 100, whatever it is. Now never I have configured the 172.168.1.2. that is perfect. But here what I did, remote AS I have configured 100, whereas the remote AS is 200. In that case what will happen, it will definitely notify, right? That's what showing in this packet capture. What is happen in the first, it sends the open message, right? So open message, who sends to whom, right? This to who, this router, right? This router sends an open message, and if I open this open message, it will says it is declaring my AS number is 200. So this router sends an open message stating that my AS number is 200. Now it's come to router 1, and router 1 sees the neighbor is configured, AS number is 100. Now what it will throw? It will throw, you can see the notification, it goes from 1.1 to 1.2, right? What it says? It says bad peer under the notification message. Alright, so it is very important to in terms of troubleshooting or understanding what is happening in this BGP network. It will notify this is your bad pair, right? I have information your AS number is 100, you are talking about your AS number 200. In that case the neighborship will be terminated and it will go to idle state, right? All right, hope it is informative. Thank you, thanks for your time. Now are you still curious and have few more time? Let's test the same in lab. Let's go to lab. So here you go. This is the two router. They are connected each other, right? Using interface Ethernet 1/0, and the IP address already I have mentioned over here, right? So here we will catch each and every message, right? Whatever I have explained in detail just before, right? So we'll catch each and every message over here, right, and analyze in detail. All right, so let's start. What is the IP? Let me see over here. Yeah, so in this interface IP address is already configured, right? 172.168.1.1, right? And let me check this IP also, router 2. Yeah, that is also configured, right? Now thing is that this both the interfaces is administratively down, right? Because our intention is to start from the scratch. We'll catch each and every message over here. That's what we are here, right? So what we'll do, first we'll configure the BGP as I told you. If you check now, let me show you another part also, right? First let me switch on the interface, right? All right, let me put the nosat command. Then again, this is the interface. Let me up. Let me make this interface up, right? Now both of the interfaces is up, right? Now what is happening? Let's see over here. Let me ping. Okay, before ping, let me capture the packet, right? Only one interface I will capture right now. Yeah, it is started. Now let me ping from here whether there is reachability to the router 2 or not. Oh my god, there is one miss. You can see the fast packet, the ping reachability fast packet is dropped because our resolution is done. Then they understand the each other IP address. Then it's the response give to us, right? Now that's what it will reflect over here. Let me stop over here. Yeah. So you can see first it's tried to broadcast, right, to understand the nearest interfaces, right. So one it's resolute his MAC addresses. This is the it's very clear, right. You can catch every packet. Here is your information, right. 172.16.1.2 is at this, right. This is how they broadcast first initially, then the ping response. These are the ping response, right. Perfect. Everything is going good. Now what we'll do now? One thing, did you observe there is no any BGP message on BGP kind of update over here, right? Now what we'll do, we'll start it over here again. Oh no. Can I start this again? Okay, no. Let me cross. Yeah. So now what we'll do, we'll configure the BGP first, because our intention is to check all the interfaces, right? BGP interfaces, how they sends the open message. So let me configure the router 1 first. Router BGP, then yeah, what is my neighbor? 172.16.1.2. the remote is you know, right? Remote is 200. Yeah, 200. And here also the same router BGP, then remote neighbor, right? 172.16.1.1, right? And the remote is okay. Remote is 100. All right. So before putting this comment, let me capture it, start it again, right? So that we can arrest all the packets. All right. Let me capture both the interfaces, right? It's very interesting, right? Hope you are enjoying. All right. So right hand side is the router 2, left hand side is the router 1. Yeah. So both the router is here. So as I said, once we configure the BGP, then immediately it start the TCP synchronizations. Once it gets done, then open message sent, right? So that's what we are here. Yeah, it's successfully done, right? You can see the TCP three-way handshake is completed, right? And then the open message been sent. Let me stop over here. First we'll understand the open message over here, then we'll start again if it is needed. So what happened, we try to capture both the interfaces. Here what's happened, the router here is the source column, right? So source, what it does, it sends a TCP request, right? Then to the destinations, then the destination reply back with the SYNACT. You can see it's very clearly mentioned, right? Let me take the VRAS, it would be easier, right? It is not coming. So anyway, so the TCP three-way handshake gets complete, then only the open message send. Who sent? The 1.1, right? The router 1 sends to router 2, then router 2 received, then router 2 again sends to router 1, right? 1.2 the source, then destination 1.2. So the open message sent, then Keepalive message sent, then the update message also sent, right? So let's open the first open message. Yeah. So here is the open message. Let me expand it out. Yeah, so what I explained in before, that open message carries few information, right? What is that? Versions, what version it carries, what version BGP version it is, then AS number. So router 1 is saying my AS number is 100, guys, to router 2, right? And router 2 will definitely reply with his response that I'll show you. And here you can see the whole time as the default, I have not changed it out right over here. That's the whole time is showing 180 seconds, right? Then below that the BGP identifier. So here you also observe, right? I have not configured the BGP identifier, though over here it is showing the BGP identifier. So how it's happened? As I told you, the formula is it will check whether it is configured. If it is not configured, then it will check the loopback IP address. If it is not there, it will take the physical interface IP. So only I have the physical interface IP. That's what it's took, the physical IP address. So in under the open message, all information is there, right? So let me close this out. Yeah, so let me open this over here, right? The response, no, don't open. Yeah, he responds. Now he is replying to this guy, right? So what happened? Again, this router 2 sends his version. Yes, my version is 4. That's what the synchronization is established, right? And the AS version, he says router 2 says router 1. My AS version is my AS number is 200. Whole time is 180 seconds. And again, the BGP identifier I have not configured. He took his own interface IP address as a BGP identifier, right? So what we understood as of now, the TCP three-way handshake perfectly we catch the packet and the open message, right? Then we'll check update message in LRI and the withdrawn route, right? All right. Now I will show you. Let me try to open, but before that I have to this is the BGP update message. Nothing is there. Let me do more on that. Yeah, let me close all these stuffs. Now what I'll do first, what is the update message? Basically update message is nothing but whatever the route I will configure, it will exchange within themselves with the update message, right? Whatever I have explained to you. So what I will do, guys, here in router 1, as I showed you earlier also, right? I will make one interface for testing only, that is loopback 0, and I'm configuring one IP address 192.168.1.1, right? 255.255.255, let's say .0. Sorry, I missed one byte is IP address, right? All right, so let me check. So I have configured the loopback address, and where I have put the interface IP address, that is the 1.1, right? And now what I'll do, I will advertise. How do I advertise? Let me go to the router process ID, router BGP 100. Now here I will advertise, right? Before that I have to capture the packet again, right? Let me advertise 168.1.0 mask 255.255.255.0, right? So I'm going to advertise this network as the update. This network should be updated to the neighbor router, right? So before that, let me capture packet again, right? All right, here you go, it's open. Now it's again started the capturing, right? So let me advertise this stuff. Yeah, I have advertises. Yeah, immediately it is advertising to this guy. I should capture router 2 as well, right? I forgot to capture. Still see what is happening. Still it should be there in router 1 also, right? So let me open the router 1. So what is under this update message? Let me open. This is the update message. What I did, yeah, here it is. here it is clearly mentioned. See what I did, I make one new network and try to advertise. So as I explained before, that it should be advertised using the update message, right? Here it is. So what I did, this network I have created, this is the prefix NLRI, whatever I have explained earlier also. This is the NLRI, right? And this is the path attribute. So what update message will contain? The attributes as well as the NLRI, right? Here you can say withdrawn route is length is 0. That I will also show you, right? So attribute is there, origin, IP, AS, path, next, stop, mid, all this stuff is over here. And the new network, whatever I advertise, that is going to update the router 1 to router 2 with the NLRI, right? So now router 2 knows this network. Let me check over here. Let me stop. Let me keep alive. I will show you later on, bit later. So what would be in router 2? Router 2 must know the network. So IP BGP, right? So here you can see this is the network he knows, and that is the valid best path, and next stop is this, right? So this router 2 knows this new network which is being advertised by router 1, and that the router 2 knows via the update message, right? And where is the update message? Here is the update message. Yeah, it's very pretty simple. It's quite simple, right? Now what we will do, now let me close all these stops. Let me close this one also. All right, everything is going good. You might enjoy this video, right? Okay, now what I'll do, I will stop the advertisement. Right? How do I do that? Router, all right, BGP 100, no network. So it will stop the advertising, right? But before that I have to capture again for you to check how it's travel. All right. So what I'm going to do, I'm going to stop this advertisement. I have stopped. Again, the update message sent to this guy, right? Router 1 sends to router 2. So what happened? Let me go there. Let me stop again, or let it go, right? So let open this stuff. Yeah, withdrawal route. Here it is. You can see. Hope you are enjoying this video, right? So this router I have stopped to advertise. Now it's withdrawn. So it shows as a withdrawn route, right? So withdrawn length earlier was 0, now it is 4. It's very simple, right? Now our objective is to check the Keepalive also. Keepalive, how do I check, right? There is nothing, as I told you earlier also, right? In Keepalive there is no data, right? Now we'll check the notifications first, then we'll come to the Keepalive. So how the notification, no, let's see, as I remove, let's see whether the route is there or not in router 2. No route, right? There is no route learn via BGP. There is no route, you can see, because I have removed the route, right? And that also reflect in the withdrawn route. And whenever I advertise, it show in NLRI, right? All right. So now we'll check the notifications. Now let me go there. So let me capture packet over here, and this guy, and this interface as well, right? Yeah, so in notifications, what we will do, we will configure a bad pair, right? So which one it is, I don't know. Below, hope it's like this, right? So that it would be easier to check immediately what is happening in router. Now what we will do, we will remove the neighbor, right? So let me go there. and never. Oh, wait a minute. What will do? Let me copy. It will be a bit faster, right? BGP. Yeah, okay. So here what we'll do, I'm gonna configure wrong AS. So it should fall under notification message if I wrongly configure anything. So let me make it no. So it is deleted. Now let me configure it again. Okay, make it 100. So what I'm doing, I'm making my neighbor as a 100 AS number 100, so that it shows me one is a message, right? Yeah, as expected it is came up, right? So let me stop over here. The notification one notification message I received, right, immediately after configure the wrong configuration of the BGP, right? So here you can see the configuration, the bad pair, right? Bad BGP pair. So what I did, let me explain over here. Now, oh, it is going faster. That's what I always stop. So if you see what is says the 1.2 to 1.1 in open message, he's saying, what he's saying, he's saying my AS number is 200, right? And immediately this guy, the 1.1 is responding with a notification message. He's saying in the notification, no, you are bad pair, right? You are not my pair, because my pair is configured 100, right? So this is how the notification immediately generated. Again, the bad pair is configured. Now if I remove the bad pair and make it correct, multiple notification is coming, right? Oh, just a minute. Make it no 2, right? Now the BGP will be established, right? Here you can see again the notification earlier we got. Now I make it correct, then again the BGP message update. Now only one option is left, that is the Keepalive message, right? So how do I check the Keepalive? As it's not contain any data, so that it's difficult to check in the packet capture, though I am trying to show you over here. Let me make it a bit bigger. So IP BGP never, here you can find out. All right, so here all this message, right, under the message statistics, here you can find out the open message, how many open message it sends and received, notification message, it is showing 0 though, then update message, then Keepalive, then route refresh. And what about the route refresh? Like if I refresh the route, right, let me show you again what is route refresh. Yeah, clear IP BGP, make it soft. So immediately you will get a route refresh notifications kind of stuff message, right? So what it says, the route getting refreshed, right? So this is how it is, the route refresh, that is the route refresh detail, counter detail over here. So this is very important to know all this in detail statistics, right? Here you can see how many prefixes counter, how many total prefixes sent and received, refresh statistics over here, local and destination port, all this stuff. So this is how you can check in detail the Keepalive message as well, right? I'm not going more detail because time is very expensive for you guys, right? So in next video I will try to explain each and every part. still if you have any doubt, right? So anyways, so if you are enjoying this video, please share, and if it is informative, please make it like also. Thank you, thanks for your time.